Let's start by reviewing some of the conic sections that we've already covered. The first one we did was the parabola, and this was formed when you have a double cone intersecting a plane such that the plane is parallel to one of the lateral faces of the cone. Second came the circle, where the plane was parallel to the base of the cone, followed by the ellipse, when the plane was not parallel to the base of the cone or the parabola. And then if we continue to rotate it, eventually we'll get this new one, which we call the hyperbola. Now, it may look like a double parabola, but does not have the properties of the parabola. This is not two parabolas. Instead, the hyperbola is something else. So in this video, we're going to look at what is it that makes the hyperbola what it is. First off, the hyperbola is a set of all points in a plane such that the absolute value of the differences in the distances from two fixed points called the foci is constant. That means if we take a hyperbola here and we pick any point on either half of the hyperbola, I pick that point on the right, the distance from that point to one of the focus, we'll call D1, and that point to the other focus, we'll call D2, the absolute value of that difference is always going to be a fixed constant. That is, D2 minus D1 is always going to be a positive constant ratio. Now, we're going to do this with an absolute value because we want it always to be a positive constant. Now, you may recall that with an ellipse, it was the sum of the distances that was always a positive constant. With the hyperbola, it's now the difference. So let's talk about some of the vocabulary that we're going to be looking at with the hyperbola. And a lot of it's going to be very similar to the ellipse. First, the distance from the center to the vertex is going to be referred to as A units. So if we have our center, and we go either A to the right or A to the left in this case, these will be the vertices. Now, not all hyperbolas are going to open left and right. Some will open up and down. The distance from the center to the focus is going to be our C value. So in this case, C0 and negative C0 to the left and to the right of center. And there's also going to be two axes of symmetry. Now, instead of major and minor axes, they do have different names. Starting with the transverse axis. The transverse axis will have a length of 2A units. And its endpoints are going to be the vertices of the hyperbola. So this is our transverse axis. If the hyperbola opens left and right, the transverse axis will always be horizontal. If the hyperbola instead opens up and down, then the transverse axis would be vertical. The other axis we're going to call the conjugate axis. The conjugate axis will always have a length of 2B units, and it's going to be perpendicular to its transverse axis through the center. The conjugate and transverse axes will always intersect at the center of the hyperbola, and there's always going to be perpendicular. So if one of them is horizontal, the other one will always be vertical. This is the conjugate axis. If the hyperbola opens left and right, the conjugate axis will always be vertical. If the hyperbola instead opens up and down, then the conjugate axis would be horizontal. Lastly, let's look at how the A, B, and C all relate. It's a little different than what we had for the ellipse. The hyperbola, C squared equals A squared plus B squared. You may recall that with the ellipse, that it was C squared equals A squared minus B squared. Now it's A squared plus B squared. Some other things we may want to look at when we draw these is going to be the asymptotes. And the hyperbola, as you recede from the center, these branches, which I've just illuminated in purple, are going to approach the asymptotes. They're never going to cross, but they are going to get close as we move further and further towards infinities, left and right. Or, yeah, we'll go with that. Okay, so let's actually look at some of the equations. Now, there's two forms that we're going to be looking at, and it has to do whether a hyperbola is going to open up and down or left and right. Let's start with this one. If we have the quantity x minus h squared over a squared minus the quantity y minus k squared over b squared equals 1, it's going to be different than the form y minus k squared over a squared minus quantity x minus h squared over b squared equals 1, and it has to do with which piece is positive. In the first equation, the x minus h squared over a squared is the positive piece, which means this one is going to open left and right. The x was the positive piece. Whereas in the other one, it starts with the y minus k squared over a squared, in which case the y value is the positive piece, and that's going to be the hyperbola that opens up and down. It has to do with which piece is being the positive piece and which piece is being subtracted. Now the direction of the transverse axis is going to go with the direction of the hyperbola. If the hyperbola is open side to side, the transverse axis is horizontal. Whereas if the hyperbola opens up and down, it's now going to be a vertical transverse axis. The center of both of these is going to be HK. The foci are going to follow the transverse axis, so if it's horizontal, then we're going to add it and subtract it to the h value, in which case it's h plus or minus c, comma k. Whereas if it's a vertical hyperbola, then it's going to be the coordinate h comma k plus or minus c. Again, it has to do whether the foci is left and right of the center or up and down. The vertices are going to do the same thing, but instead of adding c, now we're going to add a. The length of the transverse axis is always going to be the 2a, and the length of the conjugate axis will always be the 2b piece. Now this next piece for the equation, the asymptotes, let me put them up here. I'm not going to necessarily think that I would memorize this. Instead, I look at, once I draw the picture, what's the slope using the box that I'm going to draw in a moment, and then I plug in the center using point slope. Okay, so this whole b over a or a over b, we'll see that when we actually do the drawing. I don't need to memorize this. And then the rest of it is just using point slope, using hk as the coordinate. Now you may notice the plus or minus, and that's because there's two asymptotes. One will have a positive slope, the other one has a negative slope. All right, let's try it. Let's see how this works. So here, we're going to go ahead, find these pieces, and graph the hyperbola, defined by the equation the quantity x plus 1 squared over 4 minus the quantity y plus 3 squared over 9 is equal to 1. Notice that the center would be negative 3, negative 1. And let's plot that. Next, which variable is the positive piece? Here, the x plus 1 squared over 4 is the positive piece. Because x is the positive piece, this hyperbola is going to open side to side. Okay, horizontal hyperbola, which means the a value, a squared is going to be 4, which means a is 2, b squared equals 9, which means b is 3. So when we do this, because it opens side to side and a is 2, we're going to go 2 to the left, which makes negative 3, and 2 to the right of the center, which would make 1 comma negative 3. Because the b is now the 3 value, that means we're going to go 3 up and 3 down the center. Next, I'm going to take these points and I'm going to turn it into a rectangle. The rectangle will be 3 above and 3 below, 2 to the right and 2 to the left of center. It's going to look like this. I'll now draw in the asymptotes. The asymptotes will always go through the corner of the rectangle. So if I take my opposite corners of the rectangle, these are going to be the asymptotes. And it's going to be easier for me to find the equation based on just the slope of the picture instead of trying to memorize, is this a over b or b over a? I don't think about it that way. Instead, I just look at it and go, well, let's see, this one from the center goes up 3 and 2 to the right, or down 3 and 2 to the right, in which case it's going to be plus or minus 3/2 as the slope. The center is the point negative 3, say negative 1, negative 3, so I can put this into point slope, in which case the asymptotes are going to be y equals plus or minus 3/2. There's both a positive and negative slope of 3/2, times the quantity x minus a negative 1, which becomes x plus 1, and then minus 3 if we use that point slope form. Now the rest of the hyperbola, well, we know it's going to go through the center. Or sorry, not go through. It's going to go through the vertices, which were the negative 3, and the 1, negative 3. And we know it's going to open side to side. So let's go ahead and draw those in, knowing that it's going to go through those vertices. And then approach the asymptotes. Now we can go back and find where the foci are going to be. We can use c squared equals a squared plus b squared, substituting in what we have, which are going to be the 4 and the 9, which is going to be root 13. Now root 13 would be kind of hard to plot, so instead let's change it to a decimal. It's about 3.61. Now these foci, because the hyperbola opens side to side, are going to be to the left and to the right. So we'll take those and we'll add it to the h value of our center. So it's going to be the negative 1 plus or minus the 3.61, comma the negative 3. Or negative 4.61, comma negative 3 if we subtract, and 2.61, comma negative 3 if we add. And they would be right there inside of the curve. Let's try another example. Here I've got the quantity y minus 4 squared over 16 minus the quantity x plus 2 squared over 9 is equal to 1. The center would be 4, negative 2. Or would it? Careful. Because of the way this is written, notice, it's not x first this time. It's the y first, then the x. So instead, the center is actually going to be negative 2, 4. That is a really common mistake. You need to make sure that when you look at this, the x, which we write first in the coordinate, is actually at the back. The y, which is the back of the coordinate, is actually at the beginning of the equation. So make sure you actually look at it as x, y. So let's plot that. Negative 2, 4 would be right here. Which variable is positive? Well, we have the quantity y minus 4 squared over 16. That's the positive piece, which means this hyperbola is going to open vertically. So here, a squared is now 16, or a is 4. B squared is 9, which means b is the 3. So when we plot this, we're going to go down 4 and up 4 from the center, right 3, left 3, and then turn those 4 points into the box, or the rectangle, that's going to help me to find out where my asymptotes are. Connect the opposite corners to get the asymptotes. And then let's get their equations. So this time, the lines either run up 4, right 3, or down 4, left 3, which means the slopes are going to be plus or minus 4/3. We're going to use the center, negative 2, 4, when we plug this into point slope. Therefore, the asymptotes would be y equals plus or minus 4/3 times the quantity x minus a negative 2, which becomes x plus 2, and then plus 4. Where would we draw the hyperbola next? Well, it's going to go through the vertices. So the vertices were that negative 2, 8 and the negative 2, 0. And it's going to be a vertical hyperbola, so we're going to draw it to the top and to the bottom like this, approaching the asymptotes. Now let's go back and find the foci. We're going to use that c squared equals a squared plus b squared, substituting in c squared equals 16 plus 9, which is going to be root 25, or just 5. Now, because this hyperbola opens vertically, we're going to add and subtract this to the k value of our center. So we're going to take the negative 2, 4, and we're going to add or subtract 5 to that 4. So we're going to get the foci are at negative 2, negative 1 when we subtract, and negative 2, 9 when we add. And let's go and mark those to the picture. All right, so I'm going to go and stop this video here, and we'll look at the other part next, where we actually use the graph to find the equation.